Hey guys, welcome to the third day of lesson 2.2.2. Basically now we are just going to put everything together and do transformations with all the parent functions that we have talked about. So here is a lovely table that if I were you I would have very, very close to your heart in the time that we are working through Unit 2 here. It has all the parent function graphs, equations, and also general graphing forms. All right. So please remember that for reflections, that just means there's a negative sign at the front of the equation. Don't forget about that. And then here, that's just saying that there is a locator point that you use for all of these functions that starts at 0, 0. That's how you decide the left, right, up, and down movement. All right, so let's go ahead and do some practice. For the first portion of the practice here, we are going to write the equation given the description of the graph. So it's a square root function, first of all, so we know that we're going to go find the square root function and follow this general format. So we might as well just write that down. Well, I don't even know what that even was. Okay. All right. So we know it has a locator point at -3, 4. This tells us our h and our k. So our h is going to be 3 because h is always opposite, and our k is going to be 4 because k is always as is, right? Gosh darn. All right. Compressed by a factor of 0.2. This tells us that we have an a value of 0.2. All right. And lastly, we have a reflection over the x-axis that tells us we need a lovely negative sign at the beginning. So let's go ahead and write our equation. We have y equals, now a goes first. Our a value is 0.2, so we'll start with 0.2. Now remember, there is a reflection over the x-axis, so we got to throw a negative sign in the beginning. And then we do our h and k's. Now, sorry, I just keep writing the wrong things. We have an x, and then our h is +3, so we'll do a +3 in the house, and then k is +4, so we'll do a +4 outside. Okay, and that is the whole equation. For the next one, we have a line, so this is linear. That's going to be this one right over here. So we are following this general format. So once again, let's go ahead and write that. Y equals a times x minus h plus k. So the slope is 5/3, and that tells us that our a value is 5/3. And if this line contains this point, remember that's what gives us our h and k values. And on a line, we can use any point as a locator point. So we know that h is going to equal -4 because it's opposite. And then k is going to equal, let's do another color here. K is going to equal -7. All right, so we've got all the information that we need, so we can go ahead and start writing the equation. We have y equals, a is 5/3, so we will put 5/3 first. And then comes our x minus h. H is -4, so I'll do a -4 in the parentheses. And k is -7, so I'll do a -7 on the end, and I am done. That is my full equation. All right, so let's move on to the next skill, which is writing the equation when you are given the graph. Now with this one, you have to be able to recognize which graph we're even working with, like which original parent function. So if you look at this shape and we go back, we're like, which of these does that look the most like? Hopefully you would look at this one and be like, okay, this has the most resemblance. So this is the general format that we are going to follow. So let's go ahead and write that down. Let's note that it is a cubic function, and the general format looks like this. Okay, and remember with these we have to write down what the transformations are so that that can help us write our equation. So the original one, remember, has a locator point at 0, 0. So it's our job to figure out how we got from 0, 0 to this new point, which is 3, 2, right? Okay, so we know that in terms of left, right, up, and down movement, we must have moved to the right by 3 to get from black to blue. And this tells me that my h is going to be -3. And then we also know that we moved up by 2. That tells us that k is +2. Okay, and then it didn't flip or anything like that, so we have all the information we need. So we can say that y equals, we don't have to worry about a, because remember with these funky parent function graphs, a is just automatically going to be 1. So let's move on to the next portion. We have our parentheses. Now h we said was -3, so we'll put -3 inside the house. And k was +2, so we'll put a +2 outside, and we are done. Okay, on to the next one. This one is the V-shaped graph, and remember the trick I told you guys. V is for value, right? Absolute value graph. So this is the general format that we will be following. It's the one with the bars. So again, let's just go ahead and note that for ourselves here. And let's give ourselves the general format as well. You know, it's y equals a, and then the absolute value bars for the x minus h plus k. All right, now the parent function looked like this. That's what the note sheet showed us. So how did we get from black to blue? Well, this point is at 1, -2, and that'll help us determine what happened here. So we must have moved to the right by 1, and that's going to tell us that our h value must be -1, because h is always opposite, right? H is a jerk. And then k, well, we moved down 2, because we are at -2 now. So we moved down 2, and that tells us that our k value is going to be -2. All right, there is one last thing, which it's like obvious in the picture, but a lot of people just forget about it. It did flip upside down, so there's a reflection over the x-axis. So that means we're going to need to include a negative sign in our equation. All right, we're now ready. We have all the information we need. So we start with that negative sign. Then comes our a value. Now, as I said in the last problem, we don't have to worry about a, because in this it's just automatically 1. So now our house for the absolute value bar, or absolute value graph, is the bars. H is -1, so I'll put a -1, and then k is -2, so I'll put a -2 on the outside here, and that is it. We're done with that one. A good way to check these too, guys, like if you just type this equation that you came up with in your calculator or on Desmos, see if it matches the picture. If it doesn't match the picture, then that means you did something wrong. All right, finally, the last skill is to just describe the transformations based on the equation. So let's look at this first guy. We know, first of all, that because it's squared, it's good for you to note that this is a quadratic. That means it's a parabola. So we have a negative sign up front. That means there's a reflection. We have this 1/2 as an a value, which means that we have a stretch or compression. Now remember that if the number for your a value is bigger than 1, then it's a stretch. Here we have a small fraction, which means that it's actually going to be a vertical compression by a factor of 1/2. Okay, that means it's going to get wider. All right, -5 here we have for h, and that tells us that we're going to move to the right by 5. And one way you can remember this is like h is for horizontal, so you can know that this is always going to be referring to the left and right movement. And lastly, we have negative 6 here for k. That means we're going to move down 6. Okay, and that is everything for this one. So let's move on to this one. You look at this and you're like, which parent function must that be? It's the only funky one, right? This is going to be your rational function. So we'll just note that this is a rational function. And there is no reflection, there's no negative sign up front, but we do have a number on the top, which is our a value. So that means that we have a vertical stretch. It's a vertical stretch instead of a compression because the number is 3, and 3 is bigger than 1. So we got a vertical stretch by a factor of 3. We have this down here, we have the x minus 4, that's the house in the rational function. So house is for horizontal. That means negative 4 is our h. And in terms of transformations, that means we're shifting to the right by 4. And last but certainly not least, we have our k, which is this 5 here. And that tells us that we are moving up 5. All right, go ahead and give the practice problems a try. This is pretty much all for today.